Good day, everyone, and welcome to Sir Carl Easy Math. Today, we're going to tackle about the Quarter 1, Module 3 of Mathematics 8, and that is all about rational algebraic expressions. So, the most essential learning competency that we're going to discuss today is the learner illustrates rational algebraic expressions. So, what is a rational algebraic expressions? So algebraic expressions of the form n over d, where n and d are polynomials and d is not equal to 0, are called rational algebraic expressions or simply rational expressions. Right. So what are examples of rational algebraic expressions? So we have 1 over 5 or 1/5. So it's the ratio of n over d, right? So it's like a fraction. So when we say rational algebraic expressions, it is in the form of a fraction where there is a numerator, there is also a denominator. Given that all the numerator and the denominator, these are all polynomials. Okay, so we have the second example. We have x over x minus 1. We have the third example, y squared plus 3y minus 2 over 4 minus y, and negative 7 over z cubed minus 8. Okay, so if you see clearly, we have 1/5 x over x minus 1, y squared plus 3y minus 2 over 4 minus y, and negative 7 over z cubed minus 8. So the first thing that you need to consider, the numerator and the denominator should be polynomial. That's one thing to consider. It should be a polynomial. Okay. Second one, the denominator should not be equal to 0. You understand? So now, let's try to identify the following given expressions if it is a rational algebraic expression. So we're gonna put RAE, short for rational algebraic expression, or if it is not. Okay, so let us identify the first item. 5y minus 1 over 2. Okay, numerator and denominator are polynomials. The denominator is not equal to 0, so of course, I did leave. So this is basically a rational algebraic expression or RA. Right. Okay. Sorry for that. My daughter's still awake right now. So anyways, number 2. 3a over x minus square root of y. Okay. So numerator is polynomial, that's okay. But if you try to observe the denominator, there is a square root of y, which is a radical expression and not a polynomial expression. So number 2 is not a rational algebraic expression. Right. How about number 3? 2xy over 3x. Okay. So denominator is not 0. Numerator and denominators are polynomials. So this is rational algebraic expression. Right. How about for number 4? A plus 2 times b minus 3 over b minus 3 times a plus 2, or the quantity of a plus 2 times the quantity of b minus 3 all over the quantity of b minus 3 times the quantity of a plus 2. If you try to take a look at it, okay, you can just cancel actually b minus 3, a plus 2. So basically this term is just equal to 1, right? And so that is still a rational algebraic expression. Right? So number 4 is rational algebraic expression. How about for number 5? 4a plus 8b over 12. Okay? addition is still mid. Both, both numerator and denominator are polynomials, and denominator is not equal to 0, so this is an example of rational algebraic expression. Number 6, 1 minus m over m cubed. No problem with that one. That is still rational algebraic expression. Okay. Next, number 7. Okay. C to the fourth power, or C to the fourth, yeah, C to the fourth power over m minus n. Now, if you try to take a look at it, m minus m, that would be equal to zero, right? Okay. M minus m, that would be equal to zero. So since the denominator is zero, then number 7 is not a rational algebraic expression. Okay. Next, number 8. 3 minus w over 2w plus the square root of 2. Okay. So basically we have a radical sign there. Okay, square root of 2, so that is not. Okay. Number 8 is not a rational algebraic expression. Okay, and how about for number 9? 2x over 5x, or we could just cancel 2 with x. So what remains is 2 over 5, and that is still a fraction, so we can consider that one as rational algebraic expression. Right. And how about for number 10? T minus 5 over 0. Okay, take note. The denominator is 0, so it is not, okay, a rational algebraic expression. Get it? Very easy, right? Okay, so this time, let us learn also how to transform verbal phrases into mathematical expressions, because in some word problems, it is very important that verbal phrases, we can transform that one into mathematical phrases or mathematical expressions so that we can solve the problem. Okay, so let's have number 1. The ratio of a number t in 5 added to 3. Okay, so when we say ratio, basically it should be in the fraction form, right? When we talk about ratio. So the ratio of t and 5, so that is t over 5, right? Okay, so that is our ratio of t and 5, right? So again, when we talk about the ratio, that is, we can make that one into fraction form like t over 5. Added to 3, so just add 3 there. Okay, or 3 plus t over 5. It can be also, okay? Anyways, um, we have commutative property for addition. Okay, number 2, the ratio, okay, so it is in the fraction form because it is still the ratio. The ratio of the square root of 3, okay, and the number y. Okay, the ratio of the square root of 3 and the number y. So since it's the square root of 3, so it will look like this. Square root of 3 over y. Okay? So the ratio of square root of 3 and the number y. Okay. So take note of square root and just the square alone. So if the sentence or the phrase would say the ratio of the square of 3 and not square root, just square of 3, then probably you could answer 3 square over y. Okay? So do not be confused with square root and square alone. Right? Number 3, the square of a added to twice the number 8 or twice 8. So the square of a, this time we just use the word square and not square. So a raised to the power of 2. Okay, or that is a squared. Added, okay, added to twice a. So 2a, twice a. Alright, you understand? So our mathematical expression is a squared plus 2a. Next, number 4, the quotient of b. Alright, so when we talk about quotient, it is the answer for division, right? So you can have it like this. The quotient of b and 2 less than the square of b. So the quotient of b, so you write b there, over, since we this fraction bar, that it means division also, okay, 2 less than the square of b, okay? So that's it. So b over 2 minus b squared, in verbal phrase, we could say that is the quotient of b and 2 less than the square of. Okay. Number 5, the product of p and q divided by 3. Okay. So we can just simply say the product of p and q, right? Okay. So two letters actually that are side by each other. Um, we consider that one that we need to multiply. Okay, the two letters or the two variables. Divided by 3, so you could put the fraction bar there. That means also division. And you put 3 there. Right, so the product of P and Q divided by 3 is PQ over 3. Just like that. Number 6, 1/3 of the square of B. So 1/3 of the square of b, right? 1/3 b squared, or you can just simply rewrite that one as b squared over 3. Okay, and that is considered as 1/3 of the square of. Number 7, 10 times a number y increased by 6. Okay, so you can just answer that one as 10y increased by 6. When we say increased, that means we need to add. Okay, so that is plus 6. Okay, so 10y plus 6. In verbal phrase, we could say 10 times a number y increased by 6. Number 8, the quotient of cube of the number z and 3 decreased by 9. Okay, so here we have the quotient. Okay, so we are dealing with division here. So cube of z, so that is z cube, and 3, okay, decreased by 9. Right, okay, so the quotient of cube of the number z, okay, the cube of the number z and 3, okay, decreased by 9. Right, you get it? So that is just the same as z cube over 3 minus 9. Number 9, the cube of 9 less than a number double. So the cube of 9. So you just have 9 raised to the power of 3, okay, minus double. Right? So that is just equal to the cube of 9 less than a number double. Or in mathematical traits, we could have 9 cube minus double. Right? And the last number, a number h raised to the fourth power. Okay? So very easy. H raised to the fourth power is just like that. Alright. So that's it. is how you transform verbal phrases into mathematical expressions. And that is all about rational algebraic expressions. So I hope that you can identify already whether an expression is rational algebraic expressions or not. And hopefully you know now how to transform verbal phrases into mathematical expressions, especially if it deals with rational algebraic expressions. Thank you very much for watching the video, and don't forget to watch my upcoming videos also. Sir Carl is thank you and have